All right, I'm going to give you my version of the unit circle or any circle in trigonometry, and why we need it. It's really a beautiful, beautiful thing. We're going to lay a circle on top of the XY coordinate system and have this nice trigonometric connection between the two, and that's kind of the beauty of the whole thing to me. This video has been tough for me to make. I probably went through 100 different varieties of it to try and find something that works, and hopefully this one will. So just the first thing you need to know is you need to have a quick review. Hopefully if you're at the unit circle, you've already kind of went through all the trig identities and know what's going on. But so here we have a right triangle. We have theta here. We have the hypotenuse of that triangle, that length. And then the OPP stands for the opposite side of the angle we chose, the acute angle we chose. ADJ stands for adjacent. So that lets us go through our trig. Remember SOHCAHTOA. Well, sine of our angle, theta, is opposite over hypotenuse, OPP over hyp. Cosine of our angle is adjacent over hypotenuse. Tangents, opposite over adjacent. We'll scroll on down. Cotangent is adjacent over opposite. Secant, hypotenuse over adjacent, and cosecant, hypotenuse over opposite. So there's the first thing. If you don't know what those are, stop this video and go find some other videos on maybe the 6 trig identities. The other review I think that's essential for this, because a lot of teachers make their students memorize tables. I don't think you need to memorize any of the trig tables, because all you have to memorize is this triangle right here and know SOHCAHTOA. If you memorize those two things, you can generate all the tables you want. So there's a 30, 60, 90. Here's a 45, 45, 90. And so on a 60, 30, that's half of an equilateral triangle. So if we just make this hypotenuse length 2, that means this is 1. It's half of it. And this is the square root of 3, because that was an equilateral triangle I split in half. So it's as simple as 1, 2, 3 is how I help students remember that. And then you've got a 45, 45, 90. This is 1. This is 1 because it's an isosceles triangle. You could use Pythagorean theorem to find the other side, but we also, by the time you get sick of doing that, you'll figure out, oh yeah, it's always just a square root of 2. And so with that, with those two triangles, we can start generating this table. Now 0 isn't up there, and so we'll leave that out for just a second and come back to it. But here's my degrees, and I've got degrees. RAD stands for radians, right there. Radians. We got sine, cosine, tangent. It'd be easy to keep going and go cosecant, secant, cotangent on down the line. And I encourage you to do that, but I'll just show you quick on this one. So we'll start with 30 degrees. Well, 30 degrees is right here. And so sine of 30 degrees is opposite over hypotenuse, so we know that's a half. Cosine of 30 degrees is adjacent over hypotenuse, so that's square root 3 over 2. And tangent of 30 degrees is 1 over the square root of 3, opposite over adjacent, which if you simplify that, that simplifies the square root of 3 over 3. Again, I won't get into how I did that, but that's how you simplify a radical. Again, lots of videos on those. If you go to 45 degrees, doesn't matter which one of these you choose. Sine is opposite over hypotenuse, 1 over the square root of 2, which, again, not going to get into how to do this in this video, but that's the square root of 2 over 2 if it simplifies. And then same here. So this is the same, 1 over the square root of 2, adjacent over hypotenuse, which again is square root 2 over 2. And then tangent's real nice. It's 1 over 1, which just simplifies to 1. And so there's 30, 45. You could see then how you could generate 60, which is pi over 3 in radians. 45 degrees is pi over 4. 30 degrees is pi over 6. But you could go in then for 60, and you just choose the other angle, the 60-degree angle. Well, there it is. So we could do it in red quick. And so 60 opposite is now square root 3. Adjacent is 1, and the hypotenuse remains 2. And so then you can go through and generate that. And so that's a quick review of those. And you can finish this table. And you can also keep going. 90, then go to your next angle. And that's what I'll show you on this one. So what we're doing essentially with a unit circle, so we're kind of done with our review. Well, not quite. We got one more thing to review. And that's the Cartesian coordinate plane, which is hopefully something you've had since the 5th grade or earlier, since your early elementary years. So this is the x-axis, this is the y-axis. Notice I've got the quadrants marked. This is quadrant 1, this whole area over here. This is quadrant 2, this is quadrant 3, and this is quadrant 4. I left out the 1, but you've got 2, 3, 4, 5. If you go left, it's negative. And so a unit circle is a circle of radius 1, and we're going to place it at the origin of our xy Cartesian coordinate plane. And so what we've got here is 0, 1. Or, sorry, I went the wrong way. That's the other thing. I'll fill this thing clear full of mistakes. I won't catch them till later, and then I have to delete the video. So that's 1, 0 for that point right there. This point here, 0, 1. This point over here on the left, negative 1, 0. This point on the bottom is 0, negative 1. And what you can do with this is, now that it's a circle, we've got 360 degrees. If you remember, a circle rotates 360 degrees. A radius 360 degrees around a center point. And so what you do, and you always make the triangle with the x-axis for this, and you can create a right triangle where a point is a point on that circle. And now suddenly we've got our angle theta here. And this coordinate is the y-coordinate, this coordinate is the x-coordinate, and this is your radius, which in a unit circle is 1. And so it's pretty cool, because now instead of just angles and opposite sides and adjacent sides, now we've got the y value and the x value of the coordinate system, and then the radius r. So we can set up, now y is my opposite, x is my adjacent, r is my hypotenuse. And so we can go back to that review we had at the very beginning, and we can set that up to opposite is y over r. Adjacent is x over r. So we're going back through and generating these. Tangent is opposite over adjacent, which is y over x. And you can see that here. So opposite is y, adjacent is x. R is your hypotenuse. I'll put a little hype there so we have it. And you can go through and finish this whole set. Cotangent's opposite of tangent, so it's x over y. Secant is opposite of cosine, so it's r over x. And the last one, cosecant's opposite of sine, so it's r over y, your radius over your y value of your circle. And if it's a unit circle, if your radius is 1, you can use substitution now, and this is y over 1, which would just be y. So that's the beauty of the unit circle. We don't always use the unit circle, but if you want to simplify things down to their basics, you can really get into some pretty simple stuff. So sine theta, sine of an angle, is now just y, your y coordinate, on a unit circle. Cosine is x, because r is 1. Tangent wouldn't change. Cotangent wouldn't change. Secant becomes 1 over x. Cosecant becomes 1 over y. And so how does this help us? Well, if we go back to this table, now we can fill in 0. Okay, so 0 degrees, this is 0 degrees. We always let 0 degrees be on the x-axis. This is 90 degrees if we follow this around. This is 180 degrees. Going straight down, that's 270 degrees. And it's really nice to see it on this. Let me grab my mouse here. I'll take just a second. So this shows you that rotation. It also shows you the values at each one. So there's pi over 3, 60 degrees is a half, and square root 3 over 2. But notice, you can go more than just those between 0 and 90. Now we can go all the way to 360. And that green line is our terminal side of our ray. Notice the red line is our y value, and it's always made with the x-axis, always. Okay, so that's what we're really doing in kind of a dynamic way. And so we've got that angle to deal with. So, what is cosine of 0 degrees? Well, cosine of 0 degrees, if you remember, cosine is just x. So our x-coordinate is 1. So cosine of 0 degrees is 1. How about sine of 0 degrees? Well, 0 degrees, has the coordinate 1, 0. It's just your y-coordinate, which is 0. Okay. And so sine of 0 is 0. Cosine is 1. Tangent is y over x, which would be 0 over 1 for 0 degrees, and that would just be 0. Okay. What about 90 degrees? Stop the video. See if you can figure out what 90 degrees would be for sine, cosine, tangent. Well, for 90 degrees, that's the point, that's the point 0, 1. So we're dealing with 0, 1. This is your x-coordinate, this is your y-coordinate. And so 60 degrees, 90 degrees is sine is y. My y-coordinate's 1, so sine of 90 is 1. Cosine of 90 degrees, the x-coordinate is 0, so that coordinate is 0. And tangent, again, is y over x, which would be 1 over 0, and we have a problem. That is undefined. So there, if you did tangent 90 with your calculator, it would probably give you an error, a domain error. The other aspect of this, and the other table that I think you need to generate with this, is notice if you're a point over here at the left, now your x-coordinate is negative, your y-coordinate is positive, and radius is always positive. And so you can generate a table like this one, where each quadrant tells you a sign. So we'll deal with sine first. Sine and cosecant, they're the same thing. Remember, sine is opposite over hypotenuse. Cosecant's hypotenuse over opposite. So sine in the first quadrant, your y value here in the first quadrant is positive. It goes up. So, and then your radius is always positive because it's a radius of a circle. And so in the first quadrant, we're positive. All sine, cosine values in the first quadrant are positive. Second quadrant, notice again, we're going up right there with your y value. So it is positive over your radius, which is positive. So in your second quadrant, it's positive. Third quadrant, what happens there? So now in the third quadrant, and let me switch colors. Let me go to a black. So here's my third quadrant. Notice now this value is negative because it goes down. And then the radius is positive. So a negative divided by a positive is negative. Fourth quadrant, same thing. Here's my fourth quadrant. Here's a point on my unit circle. That is negative. Radius is positive. And so, whoops, wrong table. And so that fourth quadrant, sine and cosine, is always negative in the fourth quadrant. And you can go ahead and fill in all of this table, but we're already 16 minutes into this. It's just unbelievable how much information is here. But so I'll let you generate the rest of those tables yourself, and you don't have to have them memorized. They're just nice and handy if you can generate them yourselves. The last thing I'll leave you with is not necessarily the unit circle, but just any circle. Find the values of the 6 trigonometric functions for the angle theta in standard form with the coordinates 3, -4 that lies on its terminal side. Wow, that's a mouthful. Well, what that means basically is that once the 6 trig ratios, and this is a pretty common textbook problem, so you can put it up here on the coordinate plane. So 3, -4, 1, 2, 3, 1, 2, 3, 4. So it wants this, all the trig values for this if there was a circle here. Well, what you need to find is this length. Well, this is 3. This is -4. So what is this length? Well, you can use Pythagorean theorem to figure that out. 3 squared plus 4 squared equals r squared. And that's 9 plus 16 equals r squared. So 25 equals r squared. So r is 5. And it's a 3, 4, 5 right triangle. Knew that already, but it's good to, if you didn't know that, to see the Pythagorean theorem in there. And so we've got a circle of radius 5. 1, 2, 3, 4 on this thing. And I'll just kind of half draw it so that you just kind of see it. So there's our circle. And so we can draw in our right triangle here on that unit circle. Notice I went to the x-axis. That's important. And we can go ahead and fill in now all of our sine, cosine, tangent. So sine theta, because here's theta in our case. We're in the fourth quadrant. Well, sine is -4 over your radius, because this is opposite. This is adjacent. This is hypotenuse. So 4 over 5. Cosine theta, adjacent over hypotenuse. That is positive 3 over 5. Signs matter now. Sine, cosine, now let's do tangent theta. Tangent theta in this case is opposite over adjacent, or y over x, which is -4 over 3. You know, remember, this is your y value, this is your x value. So the coordinates on that circle give you the trig identities. And you keep going. I'm not going to finish the problem because we're already almost to 20 minutes. And that I've never made a video this long. That's why this unit circle deal has totally eluded me because it takes so long to do it. And usually I rely on classroom discussion to make it happen. So hope this helped. If you're still totally confused, ask me questions. I love making videos for people who ask questions about it. I've got my equipment set up. I will answer them, and maybe I can make a better video in the future based on your questions. So thank you very much. Hope this helps. See you next time.